Hello everyone, I am Jitin and I am making this video for Vidhai. Vidhai is a non-profit initiative by students of IIIT Kancheepuram to provide resources and material for national level competitive exams like NTSE and NMMS. In this video, we are going to cover Triangles chapter for NMMS 8th standard. In this video, we'll be going through these topics: congruency of triangles, similarity of triangles, Pythagoras Theorem, inequalities in a triangle, and finally area of a triangle. Uh, Let me explain what is congruency. Any two figures are said to be congruent if they have same shape and size. If you place one over the other, then they'll exactly overlap. Congruency can be used not only for triangles but also for circles, squares, anything. If you take the example of a circle, two circles will be congruent if they have same radius. So in case of triangles, two triangles are said to be congruent if they have same sides and same angles with corresponding parts. We denote congruency by this symbol. It's like an equal to and a tilde. We say two triangles ABC and PQR are congruent as in this figure if AB equal to PQ, BC equal to QR, and PR equal to AC. Also, the corresponding angles are equal. And one important note is that it will be correct to say that triangle PQR is congruent to triangle ABC, but not in some other order. The order also matters. First criteria is SAS congruence. As from the name, SAS stands for side, angle, and side. So if two sides of two triangles are equal and the included angle is also equal, then we can say that two triangles are congruent. We don't need to check for remaining sides and angles. So, for example, these two triangles, AC is equal to PQ, angle A is equal to angle P, and AB equal to PR. So you can see that this angle is included between the two sides AB and AC. Next, for ASA congruence, if two angles and the side included between them are same for two triangles, then they'll be congruent. Like over here in these two triangles, angle A is equal to angle R and angle C equal to angle P, and the included side is AC and PR over here. The next one is SSS. This is very simple. If all the three sides of one triangle are equal to all the three sides of other triangle, then they'll be congruent. The last one is RHS criteria. RHS criteria is only applied in case of right angle triangles. If you say that two sides are equal, it may be any leg of the right angle triangle and the hypotenuse. Note that it is not two legs between the perpendicular, it should be hypotenuse and any one side. Then the two triangles will be congruent. Now this completes our congruence discussion. Let's move to another property which says that in case of isosceles triangle, if two sides are equal, then the opposite angles will be equal. Over here, AB equal to AC, so angle B equal to angle C. The angle should be opposite to the side. The converse of this property is also true. If two angles are equal, then their opposite sides are equal. Now let's take an example. It is given that in a triangle ABC, AD is the bisector of angle A, and the bisector itself is perpendicular to side BC. We have to show that AB equal to AC and that the triangle ABC is isosceles. Now we did not cover what is angle bisector. Angle bisector means that it is a line drawn from one vertex to the opposite side, and the specialty is that this line will bisect the angle. So for coming back to this solution, we are given that this is the angle bisector. So in consider these two triangles ABD and ACD. First, we shall prove that they are congruent. We note that this side is common side, and this angle is 90 degrees, and these two angles are equal because it is angle bisector. Hence, by ASA criteria, this both triangles will be congruent. Now, if we know that if two triangles are congruent, then their corresponding parts are equal. This is called CPCT. Corresponding parts of congruent triangles are said to be congruent. So we showed that triangle ABD is congruent to triangle ACD. Then these first two alphabets AB is equal to AC. This is by CPCT. As AB equal to AC, then it will be isosceles triangle because two sides are equal. Moving on to similar triangles. This is another concept that when do we call two triangles as similar? Similar means that they are proportionate. If you double all the sides, then you may get this triangle, or if you triple or scale up, then you will get another triangle. So we can say that two triangles are, if two triangles are similar, then their corresponding angles are equal. Over here, this may look smaller than this one. So if you scale up this one, then you will get this triangle. While scaling up, the angle remains same, but the sides are, all the sides are increased in the same ratio. So we say that the ratio of sides is same. PQ by AB equal to QR by BC equal to CA by PR. We represent similarity as triangle PQR is similar to triangle ABC.
Can we say
Okay.
like similar triangles can also be congruent triangles?
Yeah, if the ratio of these sides is 1, then they'll
Okay.
become congruent
Okay.
triangles. We are not going to cover the similarity criteria in this presentation. Now let's move on to Pythagoras theorem. Uh, Pythagoras theorem is only applicable to right angle triangles. It is a very famous theorem. The Pythagoras theorem states that the hypotenuse square equal to altitude square plus base square. In case of this triangle ABC, BC square equal to AC square plus AB square. You can remember this like this: hypotenuse square equal to one side square plus another side square. If you flip this triangle like this, then you can call this as base and this as altitude. It does not really matter. So there are a few set of special numbers which satisfy the Pythagoras theorem. We call them Pythagorean triplets. One famous example is 3, 4, 5. So you can observe one thing that say you double this, you double this, you double this, then anyways this will be 4, 4, 4. So it will get cancelled out. Which means that if you double, triple, or multiply with any integer to these triplets, you will again get a triplet. This was an interesting fact. But it need not be true always. Like if you take 5, 12, 13, they are triplets, but they are not scalar multiple of 3, 4, 5. Now let us solve an example. We are told that a 20 feet ladder leans against a wall of height 16 feet. How far is the base of the ladder from the wall? Let us say this is the wall and this is the ground, and AC is the ladder. So we are given that length of the ladder is 20 and height of the top of the ladder from ground is 16 foot. We are required to find this length BC. So you may assume that the wall and ground are perpendicular. Then this forms a right angle triangle. So in right angle triangle, we are given two sides and we are required to find third side. Uh, so here you can definitely use Pythagoras theorem. The Pythagoras theorem states that hypotenuse square equal to side square plus side square. Substitute the values: 20 square equal to 16 square plus BC square. Then you will get BC as square root of 20 square minus 16 square, which is 400 minus 256. This is equal to 144. Square root of 144 is 12. So the distance of base of the ladder, which is C, from this point B is 12 feet. Now we'll discuss inequalities related to a triangle. There was a previous year question in NMMS from this topic, so pay attention. The first one states that in a triangle, if two sides are unequal, then the angle opposite to larger side is larger, which means that if you take two triangles and say the sides are equal, then whichever side is larger, the angle opposite to that will be larger. Next one, in any triangle, the side opposite to larger angle is longer. This is like the opposite. So if you take two angles in a triangle and whichever is greater, the side opposite to that will also be larger in length. The sum of any two sides is greater than third side. So if you are given three lengths of a triangle, then any set of numbers, three numbers forming a triangle will satisfy this property. The sum of two sides is larger than third side, and the difference of any two sides is lesser than the third side. So if you are given three numbers and you want to check whether they form a triangle, if they hold true for all three combinations of this and all three combinations of this, then you can say they will form a triangle. Now let's take an example based on the inequalities that we have seen. We are given that D is a point on side BC of a triangle ABC and AD is equal to AC. We want to show that AB is more than AD. Now, if you observe that these two sides are equal, then this ADC will form an isosceles triangle. And you know that the angles opposite to equal sides will be equal. So ADC will be equal to ACD. That's what is written over here. Since the angles opposite to equal sides are equal. Now, angle ADC is an external angle for this triangle. And you know that external angle will always be larger than this one. ADC is definitely larger than ABD. And we know that angle ADC is nothing but angle ACB. So ACB is larger than ABC. Now, you know that angle ACB is more than angle ABC. So we saw that if angle is larger, then the opposite side will be larger. Side opposite to ACB will be AB, and side opposite to ABC angle will be AC. So AB is more than AC, but AC is already equal to AD. So AB is more than AD. This gets us to the last topic in our presentation, which is area of a triangle. Now, area is nothing but the region enclosed by this triangle, and the units of area will be meter square or centimeter square or foot square. The formula for calculating area of a triangle is half times base times height. So look at this triangle over here. All the blue shaded part will be the area of this triangle. Now, the height may not always be given to you. What we mean by height over here is that the distance from this vertex, a straight line which is drawn, and it will intersect this side perpendicularly. This altitude length is called the height, and the side opposite to this vertex will be the base. So you can have three bases and corresponding three heights for a triangle. All of them will give you the same area. That's what is said over here. You can choose any side of the triangle as base, and it will have a corresponding different height. In case of a right angle triangle, this angle will already be 90 degrees. So you have one base and one height, or reverse, one base and one height. You will get that area as half into perpendicular into base in case of a right angle triangle. In case of an equilateral triangle, the area will be root 3 by 4 a square, where a is the length of the side. All three sides are equal, so you can take any one as a. That's it. We hope that you enjoyed this discussion. Please like, share, and subscribe to our YouTube channel and watch the other videos on our playlist. Thank you.